Hi everybody, in this video we're going to go over the basics of data visualization. This is our first real content video, and so there are a number of different ways, an entire field of data science. It's really hard to get started of what's the first kind of content thing that you need to learn, and there are differing opinions on the matter, but we're going to start with data visualization because I think it's the easiest way to sort of ease into data science and ease into coding in R. And so we're going to use a package called ggplot2. So now there's a book on the left and what's called a hex sticker on the right. So in the R programming language, people who use R a few years ago got really excited about these hexagonal stickers that you see on the right. And so every package, not all of them, but a lot of the packages that we interact with have a hex sticker. And so if you like them, if you love them, you can buy them and put them on your computer. That's a sort of, R status symbol. Or you can pay no attention to them all, but at all. But we're going to start with we're going to start with data visualization. And in R, the package that we're going to use for data visualization is called ggplot2. Now, here's an outline of what we're going to go over. There's a lot. So what is data visualization? We're going to look at a particular theory about data visualization called the grammar of graphics. And then we're going to look at the implementation of the grammar of graphics in R, which is called ggplot2. And there are important parts of the grammar of graphics. They are aesthetics, scales, geomes, and then other stuff. Facets, coordinate systems, and themes. Okay. Now, there are a lot of slides in these videos. I'm not going to talk through each one, but I'm going to talk over the important parts of each, and I will leave you to read the other parts. If it's self-explanatory, at least what I believe, I'll move forward. Certainly, if you have any questions, feel free to email me. And then we'll look at extension packages. So this is one package that does a lot, but graphing, as you might think, is a very broad thing, and you want to do a lot of things with graphing. And so there are over 100 extension packages that work with ggplot. So let's get started. So data visualization is important. Modern data graphics can do much more than simply substitute for small statistical tables. At their best, graphics are an instrument for reasoning about quantitative information. This is from Edward Tufte, who is a giant in the data visualization world. So graphs should do, at best, they do more than just help you. They are an instrument for reasoning. Okay, so that's important. Oh, excuse me. In 2005, a guy named Leland Wilkinson came up with the grammar of graphics. It's a conceptual framework for statistical graphics. And so it's non-language specific. The language specific R version came from a person named Hadley Wickham, who is very important. You'll hear me talk about him a lot. He came up with most of the packages, or he was involved in making most of the packages that we're going to use throughout the course. So he implemented it in what's called ggplot2. Okay, and so here's a quote from his paper that he wrote about the grammar of graphics in R. And a grammar of graphics is an answer to the question, what is a statistical graphic? And it tells us that a graph is made up of aesthetics and geometric objects. So we'll see that in a second. Aesthetics are color, shape, size, geometric objects, points, lines, bars. Okay, so basically what's going to happen is you're going to specify what type of geometry you're going to want, and it's going to do a lot of the work for you in making a graph. And so the grammar of graphics says that these things need to be true. Every plot needs these 6 things. Okay. The first thing you need is data, which is, pretty self-explanatory. If you don't have data, you don't have a graph. And these data need to have aesthetics. You can think of aesthetics as variable names in a data set. Right? You're going to have a data set. It's going to have variables in it, which are the columns. And you're going to tell the plotting machine, you're going to tell R what you want on the x-axis, what you want on the y-axis, what you want the color to be, so on and so forth. Okay, so data with aesthetics, and then you have layers of a graph composed of geometric objects and statistical transformations. So points, lines, planes, so on and so forth. I'll usually call them geomes. And then the statistical transformations is something like a histogram. So you've all taken an intro stats course at least sometime in your life, and so you know hopefully what a histogram is. And for a histogram, you need to count, you need to create bars, ranges of numbers where the data lies, and then you need to count how many data points lie in that range. That's a statistical transformation that the software is going to do behind the scenes for you. Okay, then scales. We'll learn what scales are. Basically, you need to tell, if you want a number of colors, you need to say, like, what kind of color scale do I want? A coordinate system. So are you using the regular Cartesian coordinate system or not? A facet specification and a theme. Okay, so we'll get through there. Okay, so here is the basics, a ggplot2. Okay, so now before we get started with the code and the output, you do need a few things before you can do this. So I'm going to take some time to actually do that. So the package that you're going to want to download or install and then library, and so if you've done the R homework assignments, you know what this means, and if you haven't, you should probably do them before you finish this video. Okay, but the first thing you need to do is install the tidyverse package. The tidyverse package is a package that loads a bunch of other packages. Okay, and it's what I mentioned in a previous video as doing data science the tidy way. Okay, so you only need to do this once per project if you're on Posit Cloud, or just once at all if you're using your personal machine. So don't install a package every time. Just do that once. And so if you've already done that, you don't need to do it again. What you do need to do every time is library a package. So the function is called library, open and closed parentheses, and then you put the package name like so, tidyverse. And when you library the package, now it actually didn't do that because I already did it in this session, but let me restart my R. And if I do it again, it gives me a startup message. And so inside the tidyverse, it tells you what packages it loaded. So in loading in librarying the tidyverse, you also libraried the dplyr package, which we're going to talk about a lot later on. But down here is ggplot2. And so that's the one that we're going to want. So in order for the code that I'm going to give you to run, you need to library the tidyverse first, which in turn libraries these 9 packages down here. Okay, so now back to ggplot2. Okay, the code looks like this. So code looks like this. The output looks like this. Okay, So also, another side note is that I put inside of your PDF of the slides that you'll find on D2L, you should hopefully be able to copy this code and then just paste it right into R. And I have weird formatting issues that you probably shouldn't have. And I should be able to run that, and up should pop a graph. Okay, so now let's talk about what this is doing. So I run some code and I make a graph. What's happening? So, oh, sorry, we'll go back. The first function that you see, there are two functions really that I'm calling. The first function, which is the first function, is called ggplot. So ggplot, that function instantiates. I shouldn't use that word. It starts the plotting window, so to speak. So it starts a plot. So when the ggplot call is a basic call that you're going to start every plot with. It's always going to start with ggplot. Inside of ggplot, the first thing that you need to specify is the data set that you're going to use. And so here, you'll see it says data equals MPG. So I'm using a data set that happens to be in R. Maybe I'll move to R here, make this bigger. Okay. If you just type in MPG, it's a data set that exists in base R, inside the tidyverse. But once you load the tidyverse, it loads this data set. Okay, and so you'll see inside of MPG, it talks about, well, a number of cars. So each row is a car, and there's a number of pieces of information about every car. So it's manufacturer, model, engine displacement, the year it was created, whether the transmission is auto manual, how many cylinders does it have, is it a four-wheel drive, front, rear, so on and so forth. There are 11 variables and 234 rows, so 234 cars, 11 variables. The first argument that you give, so ggplot is the function. Okay. Notice RStudio will once you start typing will give you hints, mostly helpful, only sometimes annoying. Okay, ggplot, and then when you open and close the brackets, above it in yellow is something that's also really nice and can be annoying at sometimes. Is it sort of prototypes the function for you. It tells you what the arguments are. So the first argument of the function is called data. So you need to either specify it. So you can just write MPG, and it's automatically going to put that into the first thing that it needs, which is data. Or above, like you see above in line 3, I actually specify the argument. Both work. The first one is probably safer. Things can go awry, and I'll show you later on in another set of slides how and why it can go awry. Okay, that's MPG. The second part, so I know what data I'm using. The second part, and the most important part, is the aesthetic mapping. So I would have to tell you beforehand that I want to make a scatter plot. Okay, a scatter plot, which is a plot that looks like this. Okay, with points. What do I need for a scatter plot? Well, I need an X and a Y coordinate. So you need to tell the function, what should I use for X and what should I use for Y? Both of those are aesthetics, and they both need to come from variables inside of MPG. So I couldn't use like A or B, because A or B does not exist over here as variable names. So I could use manufacturer, model, displacement, cylinders, city, highway, so on and so forth. I could use any of those inside aesthetics, but I can't use something that's not there. Or rather, it might let me, but you shouldn't. And so I told them this is what I want on the x coordinate, this is what I want on the y-axis, x-axis, y-axis, and then I need to tell it what geometry I want to use. I want to use a point. Okay. Now the important thing about ggplot is that you chain together function calls using the plus sign, which is kind of weird, but I think you'll get used to it. Okay, so I tell it what I want my x and y axis to be, and I tell it I want points, and then it does, and where should I look for the data? I should look for it in here, and it does everything else. Okay, and gives you that plot. So that's a basic plot. Here's a more exciting plot. Okay, I've added in one more aesthetic. So one more thing inside my AES call. X is still the same, Y is still the same, but I used a color argument inside of aesthetics. And so you'll see it didn't turn all of the points the same color. It actually mapped a color to a variable, and the variable was what class of car is it? Is it a two-seater, a compact, mid-size, minivan, so on and so forth. Okay, and so here is a little bit of a discussion about aesthetics. So displacement, or x, y, and color are all aesthetics. Okay, other aesthetics include shape and size. Okay, and so here's your turn. So I want you to pause the video and try this out. So I want you, there's a data set in ggplot2 called diamonds. It's about diamonds. Okay, I want you to choose one categorical and one quantitative variable to plot. Also, you need to think about what are appropriate plots for one categorical or one quantitative variable. Think like histogram, think bar chart. Okay, and so follow my general template from the previous slide. So copy and paste that code, change MPG to diamonds, and change the aesthetics and geom. So they're all going to look like, here. If you start typing geom, you're going to see all of the geoms. It's always geom underscore something. So I want a histogram. There's a histogram. I want a bar chart. Well, there's a bar chart. So on and so forth. Okay, so pause the video. See if you can do that and have some success. Okay, so here is, maybe I should have mentioned before the pause, but here's a little bit about the diamonds data set that you can look over. So aesthetics. Aesthetics are a mapping from the variables to the part of the graph. So think of this as like a function. So you're back in like algebra 2 or pre-calculus. Okay, a function, any function in general, is a mapping from the domain to the range. Okay, now that's scary. This is probably a little bit helpful. If you want something to go on the x-axis, if you want a variable, something in your data set to be part of that graph, it's going to go through an aesthetic. Okay, x-axis, y-axis, color, fill, size, so on and so forth. Okay, there are lots of aesthetics. Roughly 40. And so if you want, you can include a lot of aesthetics, but if you include too many aesthetics, your graph's going to look ugly, and so don't abuse the power. Okay, now, this is an important part of understanding aesthetics. How would I make this following plot? So think about it. This is the diamonds data set. So there's carat and price, which are two variables inside of diamonds. Okay, you may have used carat or price. And your turn. How would I make this plot? All right, so I have an example here. I'm going to try. Okay. And so there are two options. And I guess the question is, which one should I choose? And so the easy way to do this is, I don't know, copy and paste these both into the into R and see which one works. But we'll go the first one. The first one, if we try the first one, it gives me this, okay? Which of course is not the same as that top right plot. And so if we were in person, I'd ask you, well, what the heck happened? And your answer should be, well, you put color inside of the aesthetic call. If color is inside aesthetics, it's going to look for a variable called green in the data set. And so if you look at diamonds, there is no variable called green. It made one. It was all the same. And it assigns it the first color that R can think of, and that's red. So that's what you get. So it thinks green is a variable in the data set. It didn't find it, so it made it. It made it all the same, and thus you get red. And so if you move color outside, so I moved it to the geom point call, okay, and it's outside of the aesthetics, I get what I want. Okay. Now, scales. Scales tell you, well, how do I want to map color to color? Okay, so if I just do that, caret price, color is a categorical variable, so it gives it a discrete color range. Okay, but maybe I don't want that. Maybe I think that's ugly. I want a hue difference. So there is a extra functions called scale color hue or scale color blank. Okay, each of them that are separated, each of the words that are separated by an underscore means something, and I'll go over that in just a second. But here I'm changing the scale to a hue. Okay, so here's a little table that helps you think about what those scales might be, okay, for a discrete variable or a continuous variable. Okay, next, geoms, geometries. Geom is shorthand for geometries. They make up basic graphical elements, points, lines, planes, so on and so forth, and there's a lot of geoms. Okay, I have a reference guide here that you can click on if you want for details on them. And so here, I have another question for you. What's the difference between these two plots? Okay, they both involve caret and price, but they're different. So I have same x and same y axis, but one's a point, one's a scatter plot, and one's a, well, whatever that is. And the difference is the geometric object that represents the data. Okay, and so now I have a quiz for you. I want you to look through all the geoms, and I want you to try to recreate these plots. So this is from diamonds. Okay, they all have cut and price as the x and y axis. So cut by price, and I want you to pause the video and try to recreate all three graphs. Okay. So now, again, something that works well in person, but again, this is a little bit lonely when you're just watching this video. Okay. Now I want you to discuss, again, how would you create this plot? Pause the video and try it now. Okay. Now, we're going to go off of this plot. Okay. Those are called densities. Okay. And it looks a little crowded. And so now we get to one of the last things that we have called facets. Okay. And maybe I want them not all on the same plot. Maybe I want a separate plot for each of them. You can do that with a facet specification. Okay. So here is diamonds and price. I made a histogram for each, and then I used a facet wrap. So there are a few facet function calls, but the one that you'll use probably most often is facet_wrap. In there, I tell it what the variables are. Note that it's vars, not AES, which is a common mistake and was actually just changed a few years ago. Okay, and so then I can cut them up by the different cuts. Okay, this is a facet grid, so wrap versus grid. Okay, so that's faceting. We won't do a lot of faceting, but it may come in handy at some time. And the last is a coordinate system. Now, I show you how to make a coordinate system with making a pie chart. A pie chart is actually really hard to make in base ggplot. Okay, and so what I have to do is, to make a pie chart, I need to use polar coordinates. Okay, now, as a side note, I don't like pie charts, so it says ooh. If you like pie charts, I'm sorry. But here's an example of changing the coordinates to polar. Now, that's probably not what you're going to have to do. You probably won't use polar coordinates. Okay, but what you might want to do is change ratios. Okay, fix the plot ratio. Now, this is a special function, this GG variety function. It does not exist in ggplot2. So unfortunately, you cannot run this code. It won't run, it won't find GG variety. It's in a special package that I'm not going to tell you about. Sorry. And so when I try to plot a circle in sort of base ggplot over on the left, you see that the aspect ratio is not the same, and so a circle doesn't really look like a circle, and so I could use chord equal to make it look like a circle. Okay. So I do tell you where it is from. It's from a package called algstat, which I worked on at one time. Okay, so if you're really interested in doing that, you can look up that package. Lastly are the themes. Okay, so depending on whether your plot, where it's presented, some people don't like the gray theme. I personally don't like the gray theme, which is the default theme. So you can change your themes. The theme that you'll see me use a lot is theme BW, the second one over. And so you just add that function onto your end. So you just plus theme whatever to get the correct theme. Okay. Now, extension packages. Extension packages. There are lots of them. 126 right now, and so this is a specific website that has all of them. Okay, and so if you're interested, you can look through them. Okay, they each do something special. Some of them are fairly applicable. Some of them are really specific about what it wants to do, but some of them might be pretty cool to look through. So, and we will use some of these as we go through the course. Okay, so anyway, those are the extensions. Okay, now this is an GG animate, and so this is a GIF that sort of makes interactive plots. It's not really interactive, but it does make a GIF, and so you can see the plot actually move over the years. Okay, so that is it. I know this is probably a long video, but I went as sort of fast as I could, and hopefully gives you a good base for data visualization. Your first data science assignment is going to be doing visualization, and so you'll get lots of practice on it. Now, the last thing that I mentioned is that everything in ggplot has a specific structure. Okay, so you see when I say geom and then underscore, it gives you all of the geoms. Okay, and we also saw scale underscore, and so scale underscore, it has, instead of two things, so geom something. Scale, you need to tell it what do you want to scale, and then specifically how you want to scale it. So you could scale alpha, whatever alpha means. it means a transparency scale. So do you want the points to be really black, or do you want them to kind of see through? Do you want to see through them? So you go the scale, what you want, or geometry or whatever. So geom or scale. The second thing is what scale you want, and then the third is the actual scale for that specific part of the graph. So there's alpha, there's a lot of color, both the O and the OU. So something also that you may get confused by is that the main author, Hadley Wickham, is from New Zealand, as you will probably have seen in the URL for his book, R for Data Science. He's from New Zealand, and so they have the English spelling and also the American spelling. So color with just an O and color OU, they are exactly the same. So you can use the English spelling or the American spelling. You'll see a couple of different places where that is Z summarize, which we'll learn later, Z and S, so on and so forth. And there are a lot of scales. But the first thing is the geometry or the scale. The second thing for these is what type of thing that we're looking at to do the scale on. And the third is what I actually want to do. Okay, so hopefully that was helpful. And that is going to be the end of our video.